Well, all right, let's get started. Computer science is more fun than music, right? All right, so this week we're talking about testing. We're picking up the conversation we started 3 weeks ago, where we introduced very basic testing ideas, just enough so you can actually write test cases. Today, this whole week, we want to expand on that and show you more kind of just tips and tricks of how to organize your tests, how to test more effectively, and just show you things that are going to help you write your tests. All this is related to programming task 4, which is a testing programming task. So for programming task 4, you're not actually implementing any code at all. I know some of you will try. I recommend against it because you'll run out of time. There's a lot to do already. But programming task 4, what you're doing is writing your test cases for programming tasks 5 and 6. And then in 5 and 6, you'll use the tests that you wrote in programming task 4 to help you write that code, to help you debug and find all your mistakes in that code by using your own test cases. You kind of had this for programming tasks 2 and 3, where the tests were given to you, or that some of you are still working on. But the tests are given to you, and as you're working on the code, you uncomment the tests and then run those tests to be able to help you write your code. This is something we call test-driven development, where you have your test cases before you write your code. You write your tests first, and then you use those tests to help you write the code. Makes it much easier to write the code. So for programming tasks 2 and 3, you've had these tests. We just gave them to you because you weren't quite ready to write those types of tests yet until we talk about this stuff this week. And then some of it you were, but testing a linked list specifically, you weren't quite ready for. Or testing classes, we didn't talk about that yet in week 2. So we gave you the tests, and then you could feel what test-driven development is like, having those tests. For the rest of the semester, you'll be writing your own tests. So in task 4, you're writing the tests for tasks 5 and 6. Task 7, you're going to write the test for tasks 8 and 9. So you're writing your tests first and then using those tests when you actually go to implement the code. We couldn't quite do that in programming task 1. We would have liked to have programming task 1. You write the test for task 2 and 3, but after 2 weeks of this course, you're just not ready to do that kind of stuff. Didn't even know what a class or a linked list was, so it's hard to test. Where the rest of the semester, it's going to be easier to do that. There's also not going to be any slides this week. I'm not doing slides all this week. We're going to hang out in IntelliJ the whole time. My lecture style this week is going to look more like Paul's. We're going to do live coding, and I'll explain the code as I'm typing it. Since it is live demos and we're kind of off the rails a little bit, we don't have the slides guiding us. If you have questions, you want to see something that's a little off topic, I'm comfortable going there. We'll navigate to that, talk about it, and then get back to the examples. So with that, let's hop over to IntelliJ. So we want to talk about testing. We're going to write a lot of tests today. We're actually only going to write tests today. And recall this method, this plus minus. Oh, I got to break it again. We kind of talked about that 100 bug before, but I want to expose that. So we have this plus minus method that we wrote that's going to take a student's score and then return whether that score should have a plus or minus attached to it or nothing. So if the score's ones digit ends in 7 or greater, we're going to call that a plus. If it's between 3 and 6, we're going to call it no modifier. And then if it's a 0, 1, or 2, we're going to give it a minus. So this was the method we wrote. It doesn't quite completely make sense for grades, but since you need 97 to get an A+, but this is the method that we're going to test. So how do we write tests for this? So first, we would do assert true. This is basically the way we tested when we saw this method the first time. We're going to do assert true. This was a static method, so we called it through the class plus minus dot plus minus of 90. And then these are strings, so you did dot equals, and we assert that this would be A minus. Again, the grading structure doesn't make sense. If I got a 90 and I'm walking away with an A minus, kind of upset about that, to be honest. And then we would do, then we could add more test cases. 89 would be a B plus. And we add more test cases like that. So that's just getting up to speed, just reviewing what we've done so far. This is what we would do. And then we would add our, let me not do that yet. We would add our hint text. I'll talk about that in a second. But we've only used assert true so far. And I even said in lecture that we're only going to use assert true in this class. Or rather that I'll only use assert true in my lecture examples. And then you're welcome to use other methods in your code. I'll never stop somebody from using other methods. But I do want to show one more because a specific colleague of mine, Dr. Hertz, got mad at me and said, why are you using assert true for everything? Paul and I talked about it. Let's show you assert equals. So we can also do assert equals, which takes two values. And what this will do is call dot equals on those values. So if we look at the code for assert equals, and by the way, very handy thing to navigate code, do control click on something, or I'm on a Mac, so command click on a method. It'll take you to the definition of that method. And I made a mistake. I did this in the last lecture and got a little lost in Java. I know where I'm going now, but we can go through this thing. And eventually, after a whole bunch of method calls, we're going to see that it's going to call equals on your two objects. It also has other checks. Some of that was checking for null and things like that. And then we're going to get dot equals called on our objects. So it does eventually call dot equals. So the values that we compare where we say use equals, like never use equal equal to compare two strings. You've heard me say that a bunch. Never use equal equal to compare two strings. It doesn't work. It's not only that it doesn't work. If it just didn't work, it wouldn't be that bad. It's that it sometimes doesn't work. Equal equal on strings sometimes doesn't work. So you're going to get the bug, and then it'll be like, well, I've done that before, and it worked. How come it's not working now? It's one of them really frustrating, kind of strange behavior bugs that are very difficult to debug. But if you're calling equals on two strings, there's no concern. It just works for comparison. So instead of calling dot equals ourselves, which I'll always start with assert true when I first start teaching test cases so we can see what the hell's going on with these things. But now that you're comfortable with testing, you've used assert true for a bit, and you've probably seen this. IntelliJ doesn't want us using assert true for everything. So feel free to use assert equals. This will call equals on your two strings for the comparison. And then we want our hint text. It's one of my regrets so far this semester. In the handout code for the project, I didn't put hint text on any of my test cases. And a lot of office hour visits that I've had, it goes something like, this test case is failing, and I say, well, add your hint text so we know what's going on. And then the student says, I don't know what hint text is. And then I explain to them, because I didn't show enough examples in lecture, so I'll explain this is how we use it, this is what it is. I should have just put those in those test cases, since you're using those as an example for writing your future test cases. Should have put it there, but let's see this in lecture one more time so we know what these are. So int string. What I'm going to do is store what I get from this method in a string, so I'm not calling the method twice. And then the first parameter here, we can add another parameter in the front here, which is going to be the hint text. The JUnit calls it a message. I always call it hint text because it's your hint of how to help your debug process if this test fails. So our hint text, I would put something like on input 90, we got actual instead of minus. So I'd have some hint text like that to help me out in my testing. And we could run this test. This should pass. And when it passes, the hint text doesn't do anything at all. Doesn't do anything. Once our test, test was that? On a minus. Once our test fails, maybe I'm giving a student minus, minus, minus instead of just minus, then we're going to see our hint text. And you want your hint text to give you, as the name, as what I call it, implies, some hint about what to do. So we get our hint text. On input 90, we got minus, minus, minus instead of minus. That gives us a good clue as to what went wrong with our code. And when we're using assert equals, we actually get some extra output from the testing library itself, from JUnit. With just assert true, there's no information to give you. I expected false and I got true, or vice versa. It's just an assertion error. Here we get a comparison failure, and it actually prints out what we expect. Oh, and I got my parameters backwards. The expected value should always be the first thing when you're using assert equals. Let me rerun that just so it's less confusing. I did it right on the second one. How did I do it right on the second one, but wrong on the first one? So we expected minus, we got minus, minus, minus. But what it doesn't tell you what it can't tell you is what the input was for that test case. So we print out in our hint text on input 90, that's the key piece of information that I need from my hint text in this example. But we got minus, minus, minus instead of minus. Gives me some information. Now I can really look into what went wrong. I go to my code, I say, oh, I just put 3 minuses like an idiot, rerun the tests, and it'll pass. Eventually, it passes. Okay, so that's pretty much where we were. I know I already said that, but this is pretty much where we were. We talked about hint text. I just didn't emphasize it enough. I should have emphasized a lot more, because the number of issues in office hours where just a meaningful hint text would have told you exactly what your problem was, and to the point where you wouldn't even need to come to office hours. Like, all of you who are using hint text probably don't come to office hours because the hint text just tells you, here's your issue, dummy, and then you fix it, and then you don't need me or a TA. But so I got to show that more in lecture. It's so helpful. But there's an issue here, and I'm going to break this into 2 lines. You can do line breaks. Since Java requires these semicolons at the end of lines, at the end of statements, if you have a line break, Java just ignores those because it doesn't see a semicolon. So we can just split things into multiple lines, which is pretty convenient. So I'm going to split that up so we can see it. But this gets a little tedious. So let's get to the point where I want to show you a better way of doing this, I guess. Whenever we want a new test case, what do? This. And then we change this to like actual 2, actual 2, actual 3, actual 3. Or you just stuff everything in the assert statement and don't have hint text, then you don't rename variables. But once your tests get more complex, you're not going to be able to just stuff everything in the assert statement. You're going to have to create new variables and new variable names. Or maybe you copy the entire test, which is a much better way of doing it. Copy the entire test and then change the values. Those are a few ways that we can have multiple tests. And neither of those are really bad. They're not necessarily wrong. But I want to show you another option. One issue with those is that you're vulnerable to typos, to copy-paste errors. The number of times I've had students in office hours that'll do something like that, and they say, I've been going crazy for 2 hours on this. I can't figure out why this one test case always fails. And, of course, they don't have their hint text to help them out or anything. And they're not running the debugger, which we'll see on Friday, more than we did last week. And I say, well, right here, it looks like you copied this and pasted it here, but it says actual 1 and it should say actual 2. And they're like, oh, God damn it. And that's their only issue, and then everything works. You're very vulnerable to those types of errors if you're doing the cut and paste and then replace all your variable names. Vulnerable to that. To avoid that and other things and just clean things up, I like to store my test cases in a hash map. So let's talk about hash maps. So I want to store a hash map where the keys are going to be the inputs and the values are the expected outputs of the method. So here I have a method that takes an int and returns a string. I always call this test cases equals new hash map test cases dot put 90 minus. 89 should be plus. 100, I want a plus. I want an A plus if I got 100 in the dang course. And 98 should also be a plus. Oh, I don't have any test cases with neutral, so let's do a 95, should be empty string. And I have all my test cases here. Now, when I want to run all these test cases, I'm going to iterate over my hash map and then call an assert for each test case. So for int, by the way, int and integer are not the same type. They can usually be used interchangeably, but when you submit to Autolab, if you have a method that's supposed to take an int or return an int, and you're taking an integer or returning an integer, it will break in Autolab. I can't believe how often I'm seeing that issue. If a method in a homework says returns int, returning integer is not the same thing. It's not the same type. I've been seeing that a lot. It's not the same type. Just follow the types from the homework doc. I don't know why y'all are making up your own return types. Int input in test cases. Test cases.keys. And again, you can iterate over keys and values at the same time. I think it's more complex than what it's worth, at least for 116. String expected. So I expect to get test cases.get input. And if there are any questions, like a lot of this I just assume you're getting used to, you're getting comfortable with a lot of this, the loops, the hash maps, array lists, we'll see in a second. I assume you're used to all this stuff, so if anything's confusing, feel free to ask a question. I can slow down a bit and explain something. But I assume that we're comfortable iterating over the keys and values of a hash map. If not, I can explain it a little bit. I'm not going to spend a ton of time on it because we already covered it in lecture, but I would give a quick refresher if that's a question. But we're iterating over all the keys and then accessing the values. So I have my input and my expected output. I need to compute my actual output, which I'm going to grab this whole thing here. This test case can go. And I'm going to do what I used to do just for each individual test case. I'm going to do this with my variables from my hash map. So actual, I'm going to call the method. Make sure you're always calling the method that you're testing or else you're not testing anything. Get the actual. And now I'm going to check expected versus actual. And then I'm going to replace my hint string with a bit more useful information. On input, we got actual instead of expected. So everything's fully parameterized. We don't have anything specific hard-coded to a test case here. Everything's completely generic to be able to work for any test case. And if we want to add a new test case with this, guess what? We just add it. I don't know. We just add test cases. We could add test cases for days. So with this setup, it's really easy to add a test case. You just add another key value pair to the hash map. It's not that big to add more test cases, which is a setup that we usually want. We want it easy to add more test cases. So when Autolab, the incorrect solutions are giving you trouble and it says more testing, you want a setup where you can just add those tests without really even thinking about it. I'm not thinking about what my testing structure is at all anymore because I wrote it once and I'm just going to use this over and over again. I just add more key value pairs to my hash map. When I revisit this, I don't have to rethink about anything. Just add another key value pair. That's what I want. That's my goal, really, with any code. I want things easy to maintain, easy to read code. But especially with my test cases, I want easy to add more. Then we run this, and we should see it fail. So the important thing about this hint text is that we get all the information that we need when a test case fails. Because we can see what line failed by clicking this, but when we're running test cases in a loop, in this case, it's always going to be this line that failed. There's only one line that's calling an assert. So I can't just jump right to the test case and get some information out of that. I don't get any information from that. It's always going to be this test case. It's my only assert. But we do get all the information we need through our hint text, And since we're using assert equals now, we do get expected and actual. We expected a plus, we got a minus. That's a good start, but I want to know what the input was. So at a minimum, my hint text needs to tell me what the input was. My input was 100. And just to double check, we got, so actual is minus instead of plus, expected is plus. If you have your inputs backwards, expected always has to be before actual. If you have your inputs backwards, these will be backwards, and that can really be a head scratcher when you're debugging, trying to figure out what the hell's going on. So I like to still put them in my hint text to make sure that I got them the right way here, because I always mix them up. I always put them in the wrong order, at least half of the time. I feel like more than half of the time. Expected first, though. I'm getting better at it. So now we have an error here on input 100. We got minus instead of plus. Oh, crap. We got to go back and fix our code because, yeah, the ones digit is 0, and 0 is going to fall through for a minus. So we have to fix this edge case. If score equal 100, it's an int, so I can use equal, return, give them their A+. Rerun our tests. We should see them pass. Which Java takes its sweet time, passes, and we're feeling good about that. So that's testing with a hash map. We're creating a hash map. The keys are the inputs, the values are the expected outputs. Then we iterate over our hash map and call the method, test the method on each input and check to see if it returned the expected output. Any questions on this one? None questions. Nothing in chat either. All right. I'll just keep going. All right. So remember when we added two numbers? Wow, what a crazy method. Add. So let's test add. We've tested this before, so let's again start with where we were with testing. Is assert, except we're going to use assert equals now because that's where we're at in our computer science programming knowledge. Assert equals first recursion dot add 2 plus 2. See, this is where I always do it backwards. I want to call the method first. 4 is what we expect, and then this is what our actual is. And we run our tests, and it should pass. So we'd like to do the same thing with this. Oh, it does fail. That's why we test. We find our bugs. I'll do it again in this lecture, but I intentionally made the code fail to see the hint text in the previous lecture. I didn't undo my mistake there. All right, so we have a test. It passes. Our code's, we're feeling good about our code. And we'd like to do the same thing that we just did with the other example. We want to create a hash map of our test cases. But my question is, what are the keys and what are the values? So the keys, the values make sense to me to be integer because our expected output, we're going to get an integer, or an int specifically, and we're going to check that int as the value of the hash map. But what's going to be my key? The issue here is that add takes 2 parameters. So I can't just do a key of int because I need 2 of them. So what do we do? How do we set test cases up like this without going back to our copy-paste and replacing variables, or copy-paste without hint text, which I think is what I did in lecture last time. We just copy-paste without hint text and then replace the values. It's not too bad, but once your code fails, you don't get much of a hint of what went wrong, or you manually update your hint text as well. We want a nice clean way to do this. And of course, this is add. It's adding 2 numbers, so it's not too bad. We could get away with really any solution here. But things are going to get more complicated. What happens if we have a method that takes, one solution here. Let me go over one solution first. We'll just throw an array list here. We throw an array list of integer here, and just give it an array list of size of size 2 and just do get 0, get 1 on the array list. We can get both values. So that's a solution, which is it's fine. It's not terrible. It's not great either because it's not clear to somebody reading this code what that array list of integers is. You have this array list that can store any number of integers, and the way you're using it, you're always going to store 2, and then just assume that it always has 2. Easy to make a mistake and get an index out of bounds error. There's issues with this, but it's not the worst thing to do. But then what happens if we have a method? Things get more complicated. When we have a method that takes 3 parameters, not a big deal if they're ints, you just stuff 3 things in your array list. But what happens when those parameters are an int, a string, and a double? How are you going to stuff all those in an array list without some really gross code? You technically could do it, but it'll be some of the worst code out there. So how are we going to do that? What I want to show is creating a separate class. Now that we know how classes work, we can start leveraging that to help our lives in other aspects. So I'm going to create a test class, and I'm not creative today, so I'm just going to call it test class. Actually, no, I'm going to call it test case, because that makes more sense. Test case. And I want this to have variables input 1 as an int, input 2, and my expected output. Let's do expected. So I want my test case, this class, or objects of this type, to store the 3 values that I need, the 2 inputs and the 1 output. Now if I have that method that takes an int, a string, and a double, I just create instance variables with a string, an int, and a double as input 1, input 2, input 3, or name them whatever they actually represent. And I have full flexibility. I can do whatever the hell I want in this test class that I couldn't do if I just had an array of integers. That's really limiting. With a test class, I can do whatever I want. I can add extra functionality and stuff to this. So let's get our constructor and our getters and setters. Here's where I would say public, test case, and then 3 parameters. I don't know about y'all, but I don't like typing that every single time. It's a Java thing. We use private instance variables. We have the constructors, the getters, the setters. And it gets tedious to type that stuff every single time, right? So what are we going to do? Make these public? No, we don't do that. Some people do that. Don't do that. Don't make your instance variables public in the name of laziness. Please don't do that, ever. But in the name of laziness, IntelliJ does have us covered. We can go to, let me explain what I just did. I'm right-clicking and going to generate. I'm going to choose constructor, select all 3 of my inputs, all 3 of my instance variables, and bam, there's my constructor. I'm going to right-click. I'm going to go to generate. I'm going to go to getters and setters. Bam, there's all my getters and setters. Done. I don't even have to think about it. IntelliJ also recognizes, hey, there's some things in Java that you just do all the time. Let me just do that for you. Let me just do those things for you. So we get our standard, exactly what we would expect from the constructor, getters and setters, following the naming convention. Much simpler than typing all of that out every single time. So now that we have our test cases, instead of creating a hash or test case class, instead of creating a hash map, we're going to create an array list of I did that last time too, test cases set equal to a new array list, and I'm even going to do arrays.asList. And now we want to give this thing all of our test cases that we want to test. So we got to create new objects of type test case. And when we create these objects, we're just straight up thinking of our test cases. So at this point, we're at the same level we were at before, where creating test cases is no big deal at all. We just copy this line, get some edge cases in here. We just copy this line and think of, okay, I want to add 2 values. I'll stick with that. 2. And we can write test cases basically as quick as we think of them. But we've got to update our assert. So here we want to iterate over our test cases. For test case, this is where Java gets a little redundant with things. Test case, test cases. So we're going to iterate over our test cases. I'm going to call the method first so I can get my hint text being a little more meaningful. We're going to call our method first. Int actual equals first recursion of add test case dot get input 1, test case dot get input 2, and we're going to assert that test case dot get expected is equal to actual. And then for our hint text, on input test case dot get input 1. Oh, wait, what am I doing? So this is going to print out what the expected was and what the actual is. So I'm going to stick with that for telling me what I got versus what I expected to get. But I still need to get the actual input values in my hint text. I need the input values. What was being added to what that gave me this assertion error, that gave me this comparison error. For that, why don't I just print out the test case? Since we're using objects, I can write a toString method for test case and have that print out all the values of the test case that I'm interested in, which is all of them, and then not have to rewrite code for my hint text. Then in test case, we could do a string like we usually do. We don't have access to the actual value, but we're going to rely on assert equals to print that out for us, which we don't have to. You could set this up any way you want, any way that's going to give you all the information you need. But we can write a toString. So what am I going to do? Public toString. Oh, it actually did that. I'm going to have, you guessed it, IntelliJ generate that for me. So I did it just with autocomplete. Let me back up and show it the same way I did before. I expected that to not give me the whole thing that I was looking for. If you right-click, generate toString, select all your values. There are by default, and you get a toString method generated by IntelliJ. I'll just use that, especially for the sake of time in lecture right now. I'll just use their default IntelliJ's, what it generates for me. It doesn't have my this dots like I like, but hey, it's good enough. It's good enough that for not having to write anything. And I'm going to run this. Going to run all my test cases. These should all pass, unless I have a typo in my test cases themselves, which I often do. So let's break this. Break it in the same way I did before. Let's break this so we can see our hint text in action and see what we're going to see when a test case does fail with this setup. So we got our assertion error. I didn't say comparison error with strings. It's assert with ints, though. We expected 4. We got 3. It's not that helpful. It is helpful, but not that helpful. I expected 4, and I got 3. I could look through my test cases and see which one expected 4, and then, I'm just going to use my hint text. So on 2 plus 2 equals 4, that's when we got the assertion error, and that gives us a much better hint. Now we go into our code and say, okay, if the inputs are 2 and 2, one thing you can do, well, you can run the debugger, but we barely saw that. But after Friday, I'd recommend do the debugger. But without that, what I would do is go through the code. I have A and B are both 2, and trace the damn thing. Just go through the code line for line. What happens? What happens at this line? What happens at this line? Okay, if B equals 1, that's false. Else if B greater than 0. Okay, so this puts a new frame on the stack, and we start over with 3 and 1. 3, 1, B is 1, that's true. Return A, which is 3. Okay, there's my bug. Right there, something went wrong. How do I fix it? And then for this one, we would change B to 0. Now that's false. B is greater than 1. Call add of 4 and 0. B is 0, return 4. Feeling good about that. So the hint text helps you debug, helps your debug process. Go find out for those exact inputs why you're getting that output. One, trace through your code to make sure you can figure out why you're getting that output. And then two, how you're going to fix it to get it to return the expected output. Oh, let me fix it. I did fix it. And run it again. We can watch our test pass. Does the constructor method always have to have the same name as the class? Yes. That's what makes it a constructor. So if the constructor if I want to be cool and name it with a Z, I'll actually get an error. It has to be the exact same name as the class. Even if I want to be cute about it and do lowercase t here, it's not the name of the class. It has to be exactly the name of the class, or else it's not a constructor. And you can see that when we call new, we actually call the constructor method. We say new test case. That's calling a method with that name, which matches the name of the class. This is a method call. We put it on the stack with its own stack frame and everything. It is a method call, and that has to match the name. We wouldn't want this to, like if we have a class named test case, and we write our constructor to say, oh yeah, the constructor has a lowercase t, and everyone has to look at your code to see what you call the constructor. It would be enough of a pain in the ass that the Java developers just said, we're going to force you to name it the name of the class. Not even the Java developers, like just the programming community at large. Every language does that. I shouldn't say every because there's going to be one language out there that doesn't. But yeah, they got to be the same name as your class. So what we did was create a new test case class, which had the instance variables of everything that we need for a test case for the method that we're testing. We created an array list of new objects of that type with our inputs and expected output. We iterated over those test cases, called our method with the inputs to get our actual output, and then we had our expected that we read from the test case, checked if that was equal to what was actually outputted, and then have some meaningful hint text primarily containing the inputs so we can see what the inputs were that caused the error. So any questions on this example, creating a test case class? Actually, there's one more thing I want to say. You can do this in your homework. In your project, you can create extra classes like that. If it's accessed by your tests, though, make sure you create those classes inside your test package. Only when testing your tests in Autolab, it's only looking at the code in your test package. So you can create any classes you want. You can even create sub-packages to keep things organized if you want, as long as all that code is in your test package and the required test classes are named what they're supposed to be named and in the test package, not in a sub-package, because that's what Autolab's looking for. Any code that you use otherwise, Autolab's going to compile all the code you give it. And for the test, it's compiling all the code in your tests. And for the code, it's compiling all the code outside of tests. So this is perfectly valid to do in your programming assignments. With that, any questions on this one? All right, I got one more for you. All right, so 2 points I want to make on this one. The first one, we're going to test a method that doesn't exist. This is what you're asked to do on task 4. You're testing methods that don't exist. So the very first thing we want to do is make them exist. So for homework, for task 4, the first thing you want to do for each test that you're going to write is create what we call in the programming a stubbed out method. So we're going to create the method that we have to test. Here we want to write a method named 1 to n that returns an array list of integers from 1 to the input int. So we want to get just the method signature. And when the homework says write a method, it's implied that it's going to be a public and non-static method at this point. If it's going to be anything other than that, it'll explicitly say on the homework. So write a method means write a public, non-static method. So this returns an array list of integer. It's called 1 to n. And whenever I have to type a name that needs to be exact, I'm going to cut and paste that from the homework document. You better believe, 100% of the time. When I was a student or when I'm writing something to a specific spec, I'm cut and pasting that to make sure I don't make any typos. The amount of time that can be wasted if you have one typo, and this one's easy to do. If you do 1 to n with like a lowercase n or a lowercase t, like it's easy to miss something there. I'm going to copy and paste. Now I know it's named exactly what it's supposed to be named, and I'm not going to have issues when I submit to Autolab, and Autolab saying, you check your names from the homework doc, like it always says, if you have an error. I'm not going to get that for this specific instance, because I just cut and pasted it from the homework doc. I ain't taking no chances on typos. I've had enough typos in my life that took hours, so days sometimes away from me. Int n. So we're going to write the signature of the method, or the header line, everything here, that's what we call the signature. And then I'm just going to return anything. Just a new array list. It's fine. So now the method exists. We're not going to implement it. We're not going to actually write the code to implement this, but we want it to exist, and it's stubbed out, meaning the whole body of the method just does the most simple, basic nothing at all. Just returns something. Even though this is wrong on every input, depends. We'd need some more text to define what if the input is negative or 0 to figure out if this is always wrong. Maybe it's right on negative numbers, but we want to stub it out, just have it return something. That's what you do for most of homework programming task 4, is write your stubbed out methods. Don't actually implement them. If you implement them and write the tests, you're going to run out of time. That's a lot of work. That's doing 3 tasks in 1 week. It's way too much. Just write the tests for 4. Non-static just means we don't have... Non-static means we just don't write static here. So if we write static, it's a static method. If we don't write static, it's non-static. So if it's a non-static method that has return type void, then it would be public void, and then method name. So let's test this thing. We want array list of, where am I? Integer. I have 3 examples in my head. I'm getting them mixed up. Actual equals... And that's, and this is a non-static method. So the other methods, we were testing old methods that we did earlier in the semester, so they were static. Here's a non-static method. So the first thing we need to do is create an instance of the class containing the non-static method. And then we can call the method. And then we want to get our our expected, which is new array list of 1, 2, 3, 4 for this example. And I'm just going to do one test case. We're not going to do anything, any fancy setups like we did for the last 2, mostly in the interest of time. Arrays as list. Got my as list. And then our issue here, not issue, but the thing I want to talk about is how do we compare to array lists? We have a method that returns an array list. How are we going to compare them? For this example, you could, assert equals is overloaded to take array list. You could do that, but that's not what we're going to do. And more to the point, that doesn't work on the test that you have to test on your homework that returns an array list. So we need to do something else. We want to do what that method actually does, just like when we use assert true for everything. I want you to all understand what is actually happening in your code, not just call assert equals, it works. Oh, actually, I almost forgot this one. when we did have assert equals. Now that, speaking of, I want you to understand how stuff works, and then after you understand how stuff works, by all means use any tools available to you. When we had this example, if I do assert equals on doubles, the library knows the same thing you all know now. There's truncation errors with doubles. Things aren't going to work the way we want them to. We run this test fails. Those values are not equal. You can't use assert equals on doubles, but, once we see this fail, but assert equals that takes doubles can also take a third double, which is your epsilon. So if you want to compare two doubles, assert equals and give it a third argument, that's your epsilon. Once you understand, now that you understand what the epsilon thing is, comparing the math.absolute value and all that stuff, once you understand truncation errors and doubles and all that, now, I still got an assertion error, because this should be 0.1. Kind of ruins part of my example, but that should be a 0.1. But this is your epsilon, they call it delta. So now that you understand how truncation errors work, now, if you want to use assert equals like this to compare doubles, knock yourself out. So how do we test these things? Well, I'm going to write a method quickly because I am running out of time. I'm going to write a method that compares these things for me, and compare these things by checking the values of these. Now, the order matters when checking array lists. I got to make sure that they have the right values in the right order. The first thing I'm going to check is expected dot size equal to actual dot size. And then we want to iterate over the indices because we want to iterate over two array lists at the same time. So for an expected dot size, and then assert equals, I won't have time for my hint text, but assert equals expected dot get I, actual dot get I. So I want to go through each value in my array list by index and compare the values at each index to make sure they're the same in both array lists after checking if they're the same size. If they're not the same size, I'm likely to get an index out of bounds error right here. If the actual